In this video, we're going to solve a triangle using the law of sines. And I've written down the law of sines here. You can see that we have the proportion sine of A over the side A equals the sine of angle B over the side B, which equals the sine of angle C over the side C. So the most important thing as we start this problem is to label our sides. The side opposite angle A is going to be side A. The side opposite angle C is going to be side C, and the side opposite angle B is going to be side B. I'm then going to look at the information that I was given, and I'm going to look for the pair of angle and opposite side for which I have all the information. As I look at this, I see that I have angle C, and I also have side C. So I'm going to be using that to solve this triangle. I'm then going to look for the pair of sides and opposite angle for which I only have half of the needed information. And that's going to be my pair of angle B and side B. I have the information for side B, but I do not have the information for angle B. And so right away I know I'm going to be solving in my first step to find angle B. So I'm going to label my work. Here's where I'm going to find angle B. To do that, if I want to find angle B, I'm going to say that the sine of angle B all over the side B, which is 11, equals the sine of angle C, which is 34 degrees, over the sine of side C, which is 18 degrees. See, when we've set this up, we can check our work just by making sure we have the angles on top, the sides on bottom, information about B on the left, and information about the pair of side C and angle C on the right. I'm then going to solve this for the sine of B. I'm going to multiply both sides by 11. So I'll know that the sine of B equals 11 times the sine of 34 all over 18. I then need to figure out what angle, if I took the sine of it, would give me a number equivalent to 11 times the sine of 34 over 18. In order to do that, I need to use the inverse sine button on my calculator. I can find angle B if I take that inverse sine button, which remember looks like sine to the negative 1 power, and I put in sine of 34 over 18. So I've got my calculator here. I type in this, I hit the second button, then the sine button to give me the inverse sine button, and then I type in 11 times the sine of 34. I'm careful to close the parentheses after the 34. Then I divide by 18, and I get my answer to be 19.982, rounding to the nearest thousandth. And so up here for angle B, I'm just going to add that information, 19.982. I now have two of my three angles. And so I can actually just use the fact that there are 180 degrees in a triangle to find my third angle, angle A. I know that angle A will equal 180 degrees minus the size of angle C, which is 34 degrees, minus the size of angle B, which is 19.982. So angle A is going to equal 126.018 degrees. So I've now got two of the three pieces I need. I have angle B, I have angle A. So all I need to find is side A. So I'm going to use the law of sines again. Here I'm solving for a side, so I'm going to use the version of angle of the law of sines that has my sides on top. So I'm going to say that side A over the sine of angle A, which is the sine of 126.018, equals 18 over the sine of 34. Notice that on this right side here I'm using the information about C, angle C and side C. I solve this for A, so I have A equals 18 times the sine of 126.018, all divided by the sine of 34. And then I just enter this in the calculator. Notice here I'm solving for a side length, so I do not need to use the inverse sine button. I'm just going to enter 18 sine of 126.018, and I'm going to divide that by the sine of 34. I was careful to close the parentheses after I typed in 126.018 there. When I do that, I end up getting 26.036. So that is the final piece of information I need, and I have now successfully solved this triangle.